Welcome back, Linux enthusiasts. This is the 4th episode of our Linux series. If you have missed any of our previous episodes, please click on this link above. In this video, we'll be talking about permissions in Linux. If you want to learn more about Linux, you can check out our DevOps course. The link is given below in the description box. Let's start the video now. So far, we have talked about file system hierarchies and how to traverse from one location to another location. Let's talk about how to change the permissions. What are the permissions that you can see in the Linux systems, and how can you change the permissions and how can you play around with it. So you can see in the slide that for permission there are 3 commands which are mainly being used: CHMOD, CHOWN and CHGRP. But in order to understand this further, let's talk about how does a permission look like in Linux systems. So as you can see in my screen here, you can see that, if I would want to see the permission for any user, any file, so you can see, or let's say ls-al file1.txt. So the permission you see, it's like this. So I'm just typing up here, it's like this. So this is the permission which is being shown for the file1.txt, right? So now, in order to understand this, first we should review this further and understand what it is actually trying to say. So this first bit, you can think like this is nothing but file type that we have already discussed. There are 7 type of files which are present in Linux systems. The remaining 3 bits are for the owner permission of a file or a directory which it contains. The remaining 3 more are for group, or I would say mainly the primary group of the owner or the user who owns that file. And then last 3 permissions are for others. So if you break it down, you review this file has permission rwx hyphen, then it has rw hyphen, then it has r hyphen hyphen. In Linux, basically you can understand this further. So it represents a numeric values. So r represents number 4, w represents number 2, and x represents number 1. Okay. So currently, if you look at this and you understand what it is actually, so it's 4, 2 and 0. Okay, this is also same 4, 2, 0. This is 4, 0, 0. If you add this up, so you see 6, then you add this up, you see 6, and then this is 4. So the default permission for a file is 664. How do we calculate this? That it is always be like this. So there is something called umask that I will show the command. How does it define? So maximum permission on any file is always be 666, and maximum permission on any directory would be 777. So you can note this down. Directory permission will always, the maximum permission on directory will be 777, and for file by default this is what I'm telling, 666. But after deducting the umask value, the default permission comes up automatically. So for a file, if you are creating a file, usually the umask value is set to 0002, but for directory it is always set to 0022. That's why you see the file permission is always be 664, but for a file you see 644. So there is a difference here. So that's what umask and how you're calculating the permissions, and similar way we will be using the commands in order to set those permissions. So you should understand this hierarchy of the numeric notations or representations of each and every permission in Linux. R represents 4, W represents 2, and X represents 1. Okay, so I hope it's clear. So now let's talk about the commands, which basically we can play around with these commands. And one more thing is that R, you can just do read operations. R is for read, okay. W is for write, and X is for execute. So I will elaborate a bit more. Read means you are reading a file or you are reading a content inside the directory. Okay, it's just for the reading purpose. Writing means you are modifying a file. When you are modifying a file, you require a write permission on the file to be modified, or you want to create more directories or file inside the directory, you need a write permission to do that. Execute is basically being used for a directory to open it up as well as a file to make a binary file, a executable file, which means there is any command which we execute in the Linux systems on shell. Everything is having X permissions. If it does not have a X permission, which means execute privileges, it will not be able to execute it. So now let's go to the demo and see how do we see all these permissions and how do we set it up. So let's check this out. Now you see this, it's 644 here. I was talking about UMAS, so you see the UMAS for user is this one, and if I create a directory, let's say test1, and then I see the permission on directory. You see the permission is a little different actually. Test1 is nothing but a dot because it's a present directory. So the permission is RWX, RWX and RX, which means what? 775. Okay, so why is it 775 is, if you minus 777 0002, you will get 775. So, and on the file it was 6664, which is 6666 minus 0002 is 664. That's how it was coming up. So for a directory it's always 777, but for a file it's always 666, the maximum permission. Okay. Now let's try to modify the permission. You know, how do I modify the permission? So you can use command chmod, and one more thing is, here you see that the user of this test1 directory is Parallels. Parallel is the user who created this directory, and Parallels is the primary group who owns this user. The user Parallels has a primary group called Parallels. That's what it owns it. Now let's do this. Let's change the permission chmod. Currently you see there is no write privileges for others to write anything inside the file, you know, other users I meant. So but you want to give it, so you can do chmod and say others plus write on test1. So once you do that, and if you look at test1, you see an additional W has added here. Why is it added? Because we have explicitly called Linux saying that I want to modify the permission for this test1 directory to append others to have a write privileges as well. So now others can also write inside this directory, which means they can create more contents, either directories or files recursively, whatever they would want to do, they can do this. Okay, and let's say if you would want to change the owner permissions, so how do you do that? I want to reduce chmod chmod u for user. I want to reduce let's say x, you know, so I say user u minus x and then test1. Okay, now let's verify the permission. So now I don't have a permission itself. Why I don't have a permission? It's a very good point. You see this is a different error kind of altogether. We are getting it, permission denied. Reason being, in order to see the permission itself for a file, we don't have execute. You know, without that we won't be able to see the permission itself for this directory. So that's why what to do is, you should always have u plus x, which means executable permission on the directory, so that it should not show up like this. So what happened at that case is, it only had rw, then blank, and then rwx and rwx. So for user, it was not having execute permissions. So execute is basically being used to open a directory, and we would wanted to see the permission of a directory. So in order to see the permission for a directory, you need to open this up. You should have execute privileges, which we removed explicitly, and that's why you saw the weird permission error coming up, permission denied, right? So that's the reason it happened. Now let's say if I would want to remove permission of X on the group from the test1 directory, so you can do like this: chmod g minus x test1. Now let's verify the permission again. So now you don't see the X even showing up for this test1 directory in the group ownership. Okay, but you might be having a question, why is it, are you still able to execute and see the permissions? The reason being, I am currently logged in with user parallels. You can see who am I command tells me, and that user has privileges to open or execute that directory, which means able to open it. Doesn't matter what group ownership has it, but the user ownership for this directory has the privileges to open this directory, and that's why I was able to see the directory permissions. Okay, so that's how you can play with chmod command. You can set for the user, you can set for the groups, and you can set for the others. You know, with A, with O, with U, you can change it. You can just play around with it. Okay, so this is there. What if you want to give read and write permissions to the user, and group and read permissions to others? So how do you do that in one go? Is chmod user and group, I would want to give read write permissions. Okay, but for others I want to give only read permission. So you are explicitly giving two permissions in single command. For user and group only having RW, and for others only have read permissions on, let's say I have a file, in case file.txt, UG plus RW, comma, user and group, it should work. Okay, it's not working. No worries, we will try this way. U plus RW, O plus R, file1.txt. Okay, it only accepts one argument here. What if I say chmod user to have write privileges, read privileges, others to have okay, it's taking like this. And what if I say user and group RW and others to have R? Okay, so there was a space additional after the comma that should not be there. That's why we were getting that error. So if you see this now on file.txt, we have set user and group is able to read and write. You can see read and write, read and write, and for others only read permissions. There is no execute permissions. So that's how you can set up the permissions in Linux file systems. And there is another way to set it up actually with the help of numeric numbers that we have already spoken, 6, 2 and 1, right? So let's say I want to set up read is nothing but 4, right? So you can set up chmod 444 and then file1.txt. So what it will do is, this 4 is nothing but for the user, this 4 is for group, and this 4 is for others. So let's review our this thing. So now you see that permission which was earlier 664, now it is 444. So that's a difference between how did we set it up. So you can set up like this. You can also set up chmod, let's say 644 file, or yeah, this is like on complete users and groups and others. You don't have to explicitly say for user I want this, for group I want this. You can just set it up with the help of numeric notations of the permissions. So that is one thing. Now what if you would want to change the ownership of the file or a directory? How will you change the ownership, right? Ownership, what I mean is that this user, this is the user who owns the file1.txt. I want to change that ownership. So for that you have to use command called chown, and to change the ownership is, you can just say chown, you know, for a file I say John, group I don't care, chown John, and then let's say file1.txt, chown John file1.txt, have to, let's say parallel John and parallel. Okay, chmod is not going through. All right, let's check this and fix it. Invalid user, it is not able to find out the user. Do we have really such user? /home. Okay, John is there. chown 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 parallel file.txt. Okay, it's not accepting this. Let's see. Man CHOWN. You can see the examples as well in the manual command. It will tell you how to basically use it. So it says likewise staff is a group, okay, CHOWN is the user, which is root, and /u is the location, okay. So you can use, should be able to use it like this. Let's see, CHOWN. What if I say just CHOWN? Hyphen capital R. It says invalid user. What if I say some other user? Himanshu1. Operation not permitted. Okay, let's try with sudo command. CHOWN Himanshu1 file1.txt. Yeah, so earlier I was not having permissions, I guess, to change it default. So how do we identify basically a command which requires a permission? We'll talk that in a bit later, to see if as a user I have some access or privileges to execute a command. So that also we can check and verify. But now since we have changed the ownership of this file to set as a Himanshu1, so you see the ownership which was parallels before, now it has changed to Himanshu1, and the group ownership still stands the same. But what if you want to change both? So let's say CHOWN, I would want to say Himanshu1 : and then Himanshu1 to file.txt, file1.txt, still sudo. Okay, sudo, you don't want to repeat the previous command whatever you executed, but you want to append a sudo in between, in front. So you can use double exclamation mark. There is another use case has come up now. See, with the help of sudo, I should be able to execute this command. But now, since I already execute this command and I don't want to copy it and paste it again, there is a shortcut of using it via using double exclamation mark. So what it does is, it takes whatever was there in the previous command executed, just append it with whatever the keyword you are passing now. So I am passing sudo and then double exclamation, it will execute the command for me. So let's see, now I say using this. Now you can see that ownership of the file1.txt is Himanshu1, and the ownership of group ownership of the file1.txt is also Himanshu1. So that's how you can change both user and group ownership on a file or a directory. You can change that. What if you want to change the ownership of all the files and directories? You know, for example, we have a directory called mydir, right? ls hyphen, let's say if I do capital R, so mydir has this is mydir dot. mydir has user ownership is parallels, group ownership is parallels, and example.com, which is inside mydir, has same user and group ownership. I want to change for mydir also, as well as the file which is present inside mydir, all together in single command. So I can use chmod hyphen capital R, recursively changing it. Let's say username, you pass the username and then group ownership, and then let's say mydir using sudo command. So let's see what happens now. Let's use this. Now you see, for dot, which is mydir, the permission of the owner is Himanshu1, and permission of group owner is also Himanshu1. So an example.txt also same case, but for the parent directory, which was /home, in this case is still the parallels which was there. We have not changed it. We have only changed mydir and whatever the contents present inside mydir. So that's how you can change the ownership of group and user recursively for any directories. Now let's combine CHMOD, CHOWN and CHGRP. So if you just want to change the group ownership, you can use CHGRP command as well. CHGRP will help you to change the group ownership. Let's say I would want to change for my dir. Let's see what happens. I always forget to add sudo, that's fine. Let's see my dir. So now you can see earlier this was Himanshu1 for my dir present directory. Now it's parallels. It has changed with the help of CHGRP. So CHGRP you can use it for the group ownership changes. CHMOD you can use for the permission changes, and CHOWN you can use for the recursive, non-recursive user and group both changes as well, or just the user also you can use it. So that is how you can set the permissions. Now there are some special permissions also we will talk about here, because I'm expecting there are some people who are just brushing up their skills, so they should be aware about some special permissions that we have. So one of those is nothing but called set UID. So set UID is basically says that if you are setting up UID, SUID privileges for any of the file, so that file will only be executed with the power of that owner of the file. So for example, let's say the commands that we were executing so far, right? I want to see which executable file is present in the file system hierarchy, which is basically being executed. So to check that, there is a command called which command, which ls. So ls command was nothing but this binary library which is present inside /usr that we have already discussed in our file system hierarchy, right? That inside /usr all the binaries and super binary files are present. So inside that we have ls command. Similarly, there is a command called passwd, which is being used to change the password of a user. But let's say I would want to see the command location. So this is how I can see. Now let's check the permission for this. Passwd. Now you see there is a little difference in the permission what we have previously seen and what it is shown now. You see, instead of X we are seeing S there. What does this S mean? So this S is nothing but a set UID. Because it is set on the user ownership, it means that whosoever is using this command passwd will be running this or executing this passwd command with the power of that owner. Owner, who is the owner of passwd command? Owner is root. So root is a user, which is a super user, you can say admin user, whatever user you can say in Linux, who none of the restrictions of permissions, no other things you can apply on the root. Root has all the privileges, all the accesses, it can do anything in the Linux system. So that's why in the real-time environment, if you see any of the servers, your admin does not give you root access, because with root you can change anything. You can block the server, you can hack the server, you can get any data, which is confidential also for the company. So nobody will give you the root access. Only the super admin of your company, or who owns the Active Directory owner, or somebody who is managing your servers, has the access to the root user. However, they still don't use a root user, because by mistakenly if somebody has executed some commands which will break down the system, it will break or crash out your entire servers. That's why it's always preferable to use your home users with whosoever you're logging in. So root is basically the user, super user you can say, and it owns all the files and libraries by default, whatever is being created when we install the Linux OS, right? So it owns all of it. So similarly, there is one command passwd which is also owned by root user. How can we confirm this? By checking the SUID. So SUID is nothing but an ID privileges for a user owner who owns it. So whenever somebody will be executing, let's say if I say passwd to change the password, let's say if I'm changing my password, my current password and the new password, okay. So this command that I have executed and updated my password, this command was only run with the help of root user, because That's what SUID means, that the power of the owner of that command will only be executed by the owner. So that's why you think, or I also think, or we also think that the passability is being executed by who? Parallels. But that is not the case here. So passability command was executed by the root privileges. With the help of root privileges, it was able to execute. But Parallels executed it. However, root was the only one. It had to down the line execute the passability command. So that is the advantage of setting up SUIDs. Now you can set the SUID for like this chmod. Let's say user and then add s. So let's say I want to set it for file1.txt, and now let's verify. So you can see this, it's being set as a capital S. Why? Because it was set by the parallel user was executed. If it is a root user, it should be supposed to set as a small s. So any other than root will try to set it up for any other non-executable binary files. It will try to set up like this. So what if I say a chmod capital plus X and then file1.txt, then let's see what happens. Now it's set to small s. Earlier the capital X, which was executable privileges, was not set for this file. That's why it was marked as a capital S. But now as soon as I set up the binary permissions, executable permission on this file, it was set as a small s. That's why this passability command was also a executable binary file, which was having small s here in the SUID format. So that's how you can set the SUID. Now let's talk about SGID. So SGID, you can set it up like this, chmod plus s, and then whatever the file path you would want to give. So basically this is being used for I would say for the group ownership basically. So what will happen is it's mainly being used for the directories. For example, let's say if we create directory, or we already have a directory, and we set this up chmod g plus s mydir, okay, sudo. Now let's verify. So on mydir present directory, the group ownership is RWS, which means on group ownership, which is parallels, this S is being set. So any user who will be creating any content inside this my directory, but the group ownership will always be parallels. So how can I show this to you? Is that let's switch the user, switch user and Himanshu1. Okay, now I have switched the user. Let's check my home directory /home/Himanshu. Let's see if I am able to go here. I'm getting permission denied. That's okay. Let's see. Let's try sudo. Still okay. No worries. Let's do one thing. What if I switch with this user? This does not have it. And what if I try to create a directory? I will not be able to because I don't have the right privileges, but let me try. /parallels/home parallels and then mydir. Okay, I am unable to do double tap here. The reason being mydir does not show up in the parallels, because parallels also does not have privileges. So let's do one thing. Let's try to set up the privileges first on /home/parallels, or we can do one thing. Let's create this inside testing directory. Okay, I'm unable to do that. Sudo ls-al /testing. Okay, now this is created under root, so we don't want root actually. So let's choose some other location. What if I create /opt /mnt mydir opt temp. Okay, in temp we are able to do that chmod g+s /temp mydir. Okay, now let's verify the permissions /temp /mydir. So the group ownership on mydir under /temp is parallels. Okay, and it has sgid set. Now let's log in with user called Himanshu1 and let's try to create anything inside this /temp /mydir /himanshu dir. Okay, I get permission denied. That's expected. Reason being, Himanshu1 user does not have, it will be considered as a others and does not have write privileges, which means cannot write anything, cannot create any file or any directory further inside mydir. So let's explicitly give the permission first. So let's go to another terminal and then here we can give that chmod others plus write /temp mydir. Okay, now let's verify the permissions /temp mydir. It has rwx all three. Okay, should be able to create it now. Okay, now I am able to create the directory. Let's verify the permissions of the directory which I have created. Okay, there is one more shortcut I'll tell you. What if you would want to use the argument of the last command in the present command? So there is a shortcut called control dot. Option dot in MacBook, but for Windows it's alt dot, alt and then dot. If you press these two keys, the argument of the last command will automatically be taken and will be put up at the end of your current command. So now you see here, however, Himanshu1 user created a directory inside mydir, temp mydir, but the user ownership was Himanshu1, but the group ownership of the directory was parallels. The reason being, this directory mydir had the special privileges of sgid, which means that only the group owner of that directory will be replicated or will be recursively being allotted as a group owner of any file or directory on which you have created or you have assigned their privileges. So that's in order to restrict other users or group to take the ownership of any directory or file, whatever you would want to create it under. So that's how you can set up the sgid. Now let's talk about sticky bits. That is another interesting permissions. So when we talk about sticky bits, so sticky bits is nothing but the user can add the data inside a directory and a file, but cannot delete the file. That's how the sticky bit is being restricted, restricting things. So how can you set this up is using +T and then /temp. Let's check the changes, the permissions. So now you see here the T is being appended at the end of this temp mydir present directory, which means anything inside this will not be, user can create it though, but cannot be able to delete it. Who others cannot delete it, but the owner of that user that file will be able to delete it. Other doesn't matter what is the privileges set on this. Let's say for example, parallels has access on this to create anything. So let's say for this, I'll create a file touch/temp mydir say test1 okay .txt. Okay, now let's verify this /temp/mydir test1.txt. So now user ownership is parallels, group ownership is parallels. Now if Himanshu1 wants to delete this file test1.txt, which permission does this guy need is on the parent directory should be able to write permission, because write means you are adding or deleting anything from a directory. That is what write on a directory means. So this parent directory, if it has a write privileges for others, which is Himanshu in this case, should be able to do anything, right? So if you look at this temp mydir, the permission on the temp mydir is parallels and parallels, but others also has read, write and sticky bit is assigned. So it has a write privileges, which means should be able to delete whatever is inside this temp my dir. But let's try if Himanshu is able to delete it. rm-rf temp my dir and test1.txt. See, Himanshu gets the access denied, operation cannot be performed. The reason being because of the sticky bit is being set. If I remove the sticky bit, it has a write privileges, it should be able to delete it. Let's try and removing it now. chmod chmod minus t on /temp/mydir. Okay, now let's check the privileges. It does not have t now, and let's try it now. Okay, should be able to remove it. So it was restricting because of the sticky bit. So sticky bit is being useful in the scenarios where, let's say, a team has a 3 to 4 members or more than that, and a team lead do not want anybody to delete anybody's project. So let's say there are 4 users, user 1, user 2, user 3 and user 4, and team lead has created a directory where all 4 users are supposed to put their contents after their project completion. Let's say user 1 has put, user 2 has put, user 3 has put and user 4 has put. So all 4 should be able to add their content, but user 1 should not be able to delete user 2's project, or user 2 should not be able to delete user 4 project. Because that's what sticky bit is all, that's what it is trying to restrict others to delete. But you can add, you cannot delete it. So that's what the sticky bit is all about. And these are the special permissions so far that we have discussed. All right, so now let's talk about overview of sudo command. Why do we need sudo command? So since so far we have been discussing about a user does not have a privileges to execute anything because it does not have a necessary permissions to do that. Sudo, we were using sudo command so far, and you guys must have been thinking why and how to use and where to use. So sudo is basically, you can think like, you're assuming super user's permission, which is root in this case, and with the help of that super user, you are executing any commands. So that's why we use sudo commands wherever we don't have direct access to execute, open a file, create a directory inside a file or file and whatever, right? So that's why we use sudo here. So if you look at the slides, there are a few features they have explaining about sudo. It has the privileges escalation, which means that temporarily you can get the access from the root itself, and then you can execute with the power of root. And user accountability, so which means that somebody, let's say, with the help of sudo command executed anything in the systems and has done something wrong. So how will you trace that up, right? So you can check the logs in order to make sure that if any user has done something faulty in the systems, right? So it makes user accountable in order to validate that, so you can check it. Also, you can put a granular control. There is a file we will be discussing in demo, a file called sudoers, which is present in /etc directory. And with the file, you can set the granular control on the sudos. Then it basically enhances the security in order to minimizing the security risks and reduce the need of login as a root user directly. So the one I was talking about earlier, right? So none of the admin will give you super user permissions. So what they can max to give you is sudo privileges, so that restrictively you can do more things, but without any intervention of operations and permission denied errors, with the help of sudo, which will assume the permissions, will take it up from the root, and then you can execute it. But you are not directly going into the root shell and then logging it into and then performing the actions. So in the next slides, we can see the common use cases for sudo is for installing a software, you need a sudo command, because usually people don't have access to download or install the softwares. To do that, you need sudo. For managing a services, you need sudo. For system files, we talked about /root also, the files which are owned by root should not be able to accessible by any other users. Then similarly, we have already seen chmod, chown, the command which was needing the super user privileges and was missing by default. So there are further options in the sudo commands. We'll be seeing that in the demo as well. How does this option look like? So just to list the commands for the user, you can use sudo -l. Then if you want to run a command, sudo command by any user, you can use sudo -u and then username and command. Then if you want to clear the cache credential, you can use sudo -k. Then you can start a shell by using sudo -s root privileges, or if you want to start logging into root shell, then you can use sudo -i. So that is about the options and the commands what sudo has it. And if we talk about the password behavior, so we will be seeing in the demo that you can change the password inside /etc sudoers file, which contains the configurations of the sudos restrictively and minimal restrictions what you can put. And if you want, a user should not always provide its authentication password. Just with the adding of sudo should be able to execute a particular command, should be able to do that. So we will see that as well in the demo. And then how to change the file is you can use either sudo vi sudo command that can open a file directly, or we will use another option called vim. And then this is the entry that you can set it up for a user to do perform any actions. Like for example, restricting a user to a specific command, you can say username all to all, and there is no password for executing this command. So if a user use sudo command, before executing this command should not be asked for the passwords. So that's about these slides. Let's talk about the demo here. If we see the sudo, you have seen that you are already seeing that we have been using chmod and chown commands to execute with the sudo. I will show the direct configuration of sudo. How does a sudo look like? How does a sudo file look like? Let me just go to the parallels, and this is how I'll open it up. So etc sudoers is a file where user can open it and then make any changes. So these are the changes that I have already done. So let's talk about these changes. One thing I see here that I have added this entry called Himanshu1. For Himanshu1 user, I don't want password to be asked for Himanshu1 when Himanshu1 wants to execute vim command with option called etc sudoers. So vim is a command. It's basically the tool to open a file. It's basically you can do a lot of things. We will talk about vim, and these are the editors that we are having. Nano editors, vim editor, g editor. So they are editors. Vim is one of those editors. You can open a file. You can write contents inside it. So Himanshu1, whenever he opens a file, should not be able to ask for the password. That is what it means. This is the entry we have added up. Let's check and verify if really it does happen or not. So let's verify first which user I have currently logged in. So if I say who am I can see, okay, I am with Himanshu1. What was the privileges is Himanshu1 should be able to use vim on which file? sudoers file. And permission denied because I have not used sudo in front of it. What happens if I use sudo? Then I am able to open the file, and it did not ask me for the password. That's what the permission meant. What if, let's change the permission and see does it make any changes. So let's see here. If I disable this and save this file, and then let Himanshu user to sudo and this open. Okay. Let me see if there is anything else as well. Parallels, Himanshu1, okay. Add user, that is there, root holder, okay, fine, that is fine. That looks good. Okay, it still has some access. Let's verify this. Should not be able to, or maybe it takes time, or we just need to see if there is anything else has to be done. Let's just let it disable and then save it up. We'll try after some time if these permissions reflects here. Meanwhile, let's read the content. specifically for the entry of Himanshu1. Okay, sudo dot. Okay, the entry looks good. Okay, we'll come to that part. Let's just see where else we could need the sudo privileges to open the file. So there is a file called etc hosts file, which basically it's a read-only file, so you cannot write here, but if you would want to write it, you can use it with sudo. This contains the DNS information locally for your file, so now you don't see any read-only in the bottom, earlier which you were seeing it here, right? So that is what sudo gives you. It escalates the privileges and the permissions for user who would want to execute anything on the systems with the help of that. And specifically for the packages, let's say we were talking about sudo, packages, let's say apt install apache 2. So sudo already did that, but what if I try without sudo? It say could not open log, permission denied. So see, this is what the error it gives without executing with the root privileges, because this apt command is only be executable by the root user. That's what it owns. How you can check the permissions? You can see this. First, let's see which apt. It'll tell you the path of that executable. Now let's verify the permission of apt. And you see others can execute it but cannot write anything on this. So, however, there is however you are still not able to execute it for some reason. So what if I try like this /usr/bin/apt install apache 2. Okay, is the permission denied? Yeah, it should not. So there are few packages by default. You see the permission is there to execute this, but still, just to execute this command you have permission, but in order to install any packages you need permission to see and open some other internal files and directories, right? Which does not have it. The command is being executed because it has execute permission for any other users. However, the changes which this command will do, the user does not have those privileges. That's the reason you are seeing the permission denied error over here. And with the help of sudo, you are able to get it done. So now let's see that, and we saw that chmod, chown thing already, that in order to change the permission without chmod, if we do, let's say 777 file1.txt, you should never say 777, otherwise it's like something anybody can do anything on the system. That's not recommendable, but for the example I'm just showing up here. You are getting operation not permitted because it's permission denied, and when I use sudo I am able to see the permission changes here, and you see 777, which is read write x and read write x. So that is one thing. Now let's say if you would want to use sudo command with the help of some other user, if this user is still legitimate or not, we will get to know unknown user. So let's use some other user. Let's say Himanshu1 and then home Himanshu1. So with the help of Himanshu, one user, being as a parallel user, I have executed his home directories command and able to fetch the files, what all files this person has it. So that is the help of sudo. As a user 1, you want to see the content a user 2 has it in its own directory, home directory, whatever the content he kept it. How do you see that? With the help of escalated privileges, which is nothing but sudo. So that's how it helps you to run any other user's privileges to execute their home directory commands and stuff. Similarly, for any services to restart, there is a command called systemctl that we'll be talking in another session. And if you say apache 2, usually it requires a password. Let's say if I still give the password to it and see if it works. Okay, it requires, and then without sudo it does not require anything. It just allows user to do anything. Maybe systemctl directly can start this service. That's why it did not ask for, it did not say the permission denied or some errors. But if I change password of some other user or something else, then it might ask for the sudo privileges to be there. Otherwise, it will say operation permission denied. It's not allowed people to do any operations on top of it. So that's how it can, and you can list basically. See, you can list the permissions what all are set here. For example, currently we have set up for this users parallel may have running following commands on Ubuntu. So these are the 3 permissions you do see here. What if I just change this vim sudoers what if I just delete this and just save it up. Now let's see. Okay, that's fine. Now, and if you want to extend the sudo timestamps, you can just that is the time before you are prompting for your password again. So sudo -v, or run as a shell of user sudo -i. You can just execute as a root user. So now if I check which user I am currently in the root. So that's the advantages. Also, you can do sudo su, which also does user root to login, but this is not a login kind completely, because whenever any user logs into the system, Linux systems, it directly should by default goes to its home directory. Earlier, when I used sudo -i command, root user was logged in, but the directory was his home directory, which was /root. But now, when I do sudo su, it has changed the user. It has logged in as a root. However, the pwd, if I see, which is home parallels. So let's see this way, and now I see pwd, you see /root. So that's a difference between sudo su and sudo -i command. Let's see if those permissions are still kicked in or not, and okay, still able to access it. Okay, we'll check that part. It should ask for the permission actually. What if I let's try here in this terminal. Let's exit this and say sudo, say switch user -himanshu1 password, and let's say sudo vim /etc sudoers is still read only. What if I make any changes? It's read only, so which means user should not be able to write anything. It was able to do that. We'll look into this permissions, why did not affect. So yeah, so that's all about the sudo privileges that we see here. That's a wrap for Introduction to Linux and Open Source. But don't stop here. We have got plenty more episodes coming up in this series. Make sure you subscribe to our channel and hit the notification bell so that you don't miss the next episode. Got questions? Drop them in the comments and I'll be happy to help.